system, and whether the embedded system comes with the limited size of a memory or it got a bulk memory thing, and what and all the types of memory are being used a lot in an embedded domain, and what is this RAM, what is this ROM, what is this .bss, what is this flash, what is this heap stack, and what is this dynamic allocation and statically allocation, and what is this dynamic linking, static linking. All those things we'll try to cover up in this video. And one more thing is the tab which I'm using right away is come with a pen. This pen sometime it's working fine, sometime it's not working. I don't know like how long it will work smoother. Till that time I'll you know till that time I'll cover all the things. If it stop in between, then I'll finish and I'll upload uh, the semi video, and the continued one I'll be uploading in coming video, yeah, in next video. So let's start then. So now memory. Okay, so when I say memory, basically there are two types of memories majorly. One is random access memory, and second one is read only memory. And one more thing is don't concentrate on my handwriting, since I'm using pen in a tab mode. It's not an user friendly, that's why just forgive me about this handwriting thing. So anyway, concept for us, what important is a concept. So if we are clear with the concept, then it's well enough. Not why we will check the how the handwriting is being written here, all those stuff, right? So yes, read only memory. Again, in the read only memory there are parts like flash memory. There is a EEPROM, and a lot of things will come under read only memory. And read only memory is nothing but a ROM, and this guy is a RAM. So in the random access memory, there is .bss, there is .data, there is a stack, there is heap, there is SRAM, there is DRAM. These guys will come under the random access memory. So now, let's say you are writing a program called hello world. Okay, all the instruction set of a program. So what and all the program which we have written, all the instruction set of this program will be stored in the ROM, in the .text format. That's why whenever you do power off your device, still you will see your program alive there. So because it is being stored in the read only memory. And what does the random access memory or RAM will store is, let's say you are let's talk the segments of the RAM. So let's say .data, .bss, stack, heap mainly. So what .data will contain is, you you have initialized some, you have declared some variable globally or inside the locally with the static access modifier. The access modifier, right, like static, auto, register, extern. This guy will tell the compiler like how to or where to store the particular data. So if any variable which is there inside the local, which comes with the static access modifier, then if it is initialized, then it will be stored in .data, like int a equals to 10, and it is comes with a static keyword before as a suffix prefix, then it will be stored in the dot. Or if something which is declared in the global before the main, and if it is initialized, then it will directly go and get stored in the .data segment. Okay, and what .bss will stored is, .bss will be storing the variable declared which are declared globally or which are declared inside the main, but with the static keyword, but they are not initialized, they are not assigned any values yet. So such guys are will be stored in the .bss segment. Let's say there is an int main program, and inside int main I have written int a equals to int a. I'm not initializing it, and I'm making it as a static. So this guy will directly go and get stored in the .bss segment, or else before the main I'm making something as int a, and this is declared globally, and it is not initialized yet. So again this guy will be stored in the .bss segment. Now what stack contains and what is heap. So you are allocating or you are declaring and initializing a variable statically during the uh, uh, during when you are writing a program, then only without using any malloc or calloc you declared a variable and you initialized or not initialized, it doesn't matter. That guy will be stored in the stack. Let's say inside the int main you are declaring inside the main you are declaring int a equals to 10. So it doesn't, it's not a pointer, it's a variable which is declared, but it's declared in the static time, so it will be stored in the stack memory. It doesn't matter whether is it initialized or not initialized, but if it's there in the local, so it will be stored in the stack. And what the heap guy will be having is you are allocating a memory runtime. Runtime means you are allocating via malloc, if you are allocating via calloc, if you are allocating via realloc. If you are allocating a memory runtime through these APIs, then this memory will be allocated. Since it's allocated in runtime, this guy will be storing the data. The data will be being stored in the heap memory. Okay, and uh, how to use the malloc? To use the malloc, there will be a standard library stdlib.h, and again you can link this library using static linking, and there is a dynamic linking. And how does the static link and dynamic library linking works, I'll cover in the other videos. If I focus on this thing, this gets itself take at least 2 hours, so let's not focus on that. We'll just see what are the required things for achieving the malloc. So now comes we are done with the library implementation. So we have written std lib.h. So the malloc, so the malloc, the return thing is always an integer pointer. Okay, if you are using a character, if you want to allocate memory for a character, the return type should be character pointer, like that. Let's say int a equals to, the return type should be an integer pointer malloc, and size of int, it can be 4 byte, it can be 2 bytes, depends on the compiler, depends on the environment. If you are working at 32-bit operating system, it will be, I mean depends which operating system you are using, but mainly integer will be 2 bytes or 4 bytes. If you are using short, it will be 1 byte. If you are using uint 16, it will be 2 byte. If you are using uint 32, it will be 4 byte, like that. Okay, you just focus for the malloc. The parameter should be passed is size of parameter, how much size you want to declare inside the memory. There is a memory, contiguous memory like this, and if you make in malloc size of 4 bytes, these many 4 bytes will be allocated for this variable, like that this thing will work. And what are the difference between malloc and calloc and realloc? All these are part of dynamic memory allocation, but malloc will allocate memory but not initialize it with 0. What does calloc do is it will allocate memory and it will make uh, all the memory initialized with 0. It will initialize the allocated memory as a 0. And realloc, what does realloc do is it will resize the allocated buffer. Let's say with the malloc you allocated a buffer of 5 byte, so with using a realloc, you can resize it. You can make it 10 bytes, you can make it 3 byte, like that. Realloc will help you. Okay, next is why, I mean, stack or static memory allocation or dynamic memory allocation, which is more important? From my perspective, being an embedded guy, I would suggest that you better allocate the memory statically. Why? Because it doesn't lead for any fragmentation. Because if you are allocating a memory, if you are not freeing it properly, or if you free also, it will just divide a contiguous memory. Like this memory, let's say using a dynamic memory allocation, you used this much space, okay, inside the contiguous memory. But the thumb rule is what and all dynamically allocated memory using malloc, after its use we have to free it. We have to freeze. If we free that, we can reuse the same memory, but in static it's not possible. This is one good thing, but what this guy will lead is, there is a continuous memory and you are allocating this much memory, and after usage you are freeing this memory. This memory and this memory are got separated. Now there is a fragmentation. This guy broken up with this guy, like that it will create fragmentation within inside the entire memory range. So short fragmentation will happen. So this is not the good behavior, since we got very limited size of memory. In that also we are doing this much thing, means again it will be a problem for everybody. One thing, the controller which I'm using right away for this project, that got only 64 KB of RAM. Just imagine, with just a 64 kilobytes of memory, I'll have to manage everything. You just think the phone which we are using right now has around 32 GB RAM for our data. It got a 32 GB RAM. You just compare the 32 GB RAM with this 64 kilobyte, that is gigabyte, and this is kilobyte. You just can think how much limited size we have for this. So I suggest you guys that don't use the dynamic memory allocation every time. Whenever required, then only you use it. And also avoid using wild pointer, null pointer, dangling pointer, like that. If you declare any pointer, let's say int a equals to, you just declared you are not using this is a wild pointer, because this guy will not be uh, uh, pointing to any proper memory address. If you dereferences, it will sometime it will give a fragmentation. You may be observed, like whenever you compile your program, sometime you will see the segmentation fault, sometime you see the fragmentation point. These because of this pointers. Sometime what happens is, if you, and the pointer, you free it, but again you dereference the pointer. That is let's say the intake, I mean to this pointer you are freeing, okay, a, and again you are dereferencing the same pointer. This guy will lead segmentation fault. All those things will come into picture. Uh, we have to be very careful with these things. Okay. This pen stopped working now, so I think this much for this video. I'll upload the other things. The other coming things are very much interesting. These are just the basic which I covered here. So in the next video, maybe tomorrow or day after tomorrow, I'll upload one more video. In there I'll go in depth, how the contiguous memory, how, I mean, how we will allocate those. Many people will be knowing, but how they go and sit inside the memory, in which format they will go and sit inside the memory, how does the memory made, in detail we will see. That's pretty much interesting. We will cover in the coming video. And one more intention is, I this why I'm doing, not because I just I mean I want to earn money on, nothing like that. There is no that intention behind this. I just want to be focused, uh, and I'm getting interested to do this stuff. Okay, take care, bye.